Hello everyone, welcome to today's class. In this lecture we are going to continue with the topic of integration. The standard results will be our next subtopic. Okay. So again we are going to look for some additional formulas. Okay. This is the first formula. Okay. Square root of x square minus a square, the integration is 1 upon 2a log x minus a log x plus a. Okay. Consider this as your basics. We'll use this to solve questions slightly at a higher note, but this is something which you can derive also, but will not waste the time in deriving these results. Let's just focus on the application part of it. This is one of the result. The remaining results, so x square minus a square is 1 upon 2a log x minus a x plus a square minus x square is 1 upon 2a log a plus x upon a minus x. Now if you want, you can learn this also, okay, but look at this result. You take negative common, it becomes this. So the answer of this should be the same of this, but with a negative sign. But sometimes the options are not given like this, so learn both ways. X square minus a square is x minus a x plus a square minus x square is a plus x a minus x. Okay, the order changes, the sign changes. 1 by 2a. Then 1 upon x square plus a square, the integration is 1 by a tan inverse x by a plus c. Okay. Then I think the recommendation is to go for the fifth result first. Okay, a square minus x square. Okay, this is kind of like 1 minus x square, so you can relate that the answer will be sine inverse x by a. But remember, there is no factor of 1 by a in this, whereas in the case of tan inverse there is a factor of 1 by a. Okay, and the last two result, what if the square root of x square minus a square and x square plus a square is there? So both of these results are pretty much the same. The answer is log mod x plus whatever is in the denominator square root, same thing. Whatever is in the denominator square root, same thing. Okay. These results are being derived from substitutions. Okay. So learn it like this: x square plus a square in the square root, log x plus whatever is the denominator. This is same thing: x square minus a square log x plus whatever is in the denominator. Okay, pretty much both are same. All right. Now let's look some question. First, let's get command over these formulas, and then we'll see the other variations of this format. Okay, let's look at all three questions. So we have to integrate this with tx. First of all, the power is 6. That's a big power as such. But look at this, 3x square. This is differentiation of something. What is that something? X cube. If I take x cube as t, then 3x square dx is dt. So we'll use this. Integration, numerator becomes dt, denominator becomes x raised to power 6 can be rewritten as x cube whole square. So basically your t square plus 1. If x cube is t, x raised to power 6 is t square. And now this is standard, 1 upon t square plus this is 1 can be rewritten as 1 square. So this is 1 by a, means 1 by 1 tan inverse x by a. Okay, x by a means t by a as such plus c. So this is tan inverse t was x cube by a, what was a as such, a was 1. Okay. This is my x, this is my a. Okay. Plus c. That's the first question. Let's look at the next one. Again, very direct. This one has again integration this. The good thing is directly square root 1 is there and 4x. You look at this, both of the results, they are perfect square. So I can rewrite this as 1 upon square root of 1 square plus 2x whole square dx. Okay, and consider this as your a, this as your capital X. Okay, in order to avoid the confusion, I'm calling this 2x as capital X. Okay, so what will be the answer? Square root of x square plus a square. Okay, the answer is log, and it will be mod of, this is if the formula is x square plus a square, then it will be, I'll write it first, log capital X plus square root whatever is the denominator, that is x square plus a square. Okay, what is our capital S as such? Capital X is 2x plus, then square root of 2x whole square is again same as 4x square plus 1. Okay, but remember there is a coefficient of x present, so still we have to use the format of ax plus b. Okay, that means there will be a coefficient of 2 in the denominator, 1 by 2 plus c. So remember, ax plus b format is still applicable. That is the significance. Ax plus b will be continuing with all the formats. Okay, it will be always present. Whenever you see coefficient of x and you see a standard formula, you apply that. Same way you can do the next question also. Okay, pretty much the same idea. They have already created a whole square. Okay, I'll get the third question separately. Let's leave it. Let's look at the third one. So integration dx. This time this is your capital X square, and that's again 1 can be written as 1 square, so a square. So a is 1 clearly, and your capital X is 2 minus x. Okay, so the integration is again log mod x plus same denominator. Okay, so this will be log mod. First I'm again writing this, but you don't have to write if you are comfortable. Once you are comfortable with this, you can stop writing this, plus c. Okay, so what was our x? Log mod x is actually 2 minus x, then what is in the inside the square root, same expression, 2 minus x whole square plus 1 plus c in the mod. But remember again the coefficient of x here. What is the coefficient of x? Minus 1. So additionally one negative will come here. Okay, in the denominator as such, 1 upon minus 1, that is effectively negative. You can solve this slightly further by opening the whole square and getting this simplified. Not to worry about it so much. Okay, next. Let's take question one by one now. Okay, same idea again. Let's get comfortable with the format. This time a square minus x square. This is a square minus some x square. So first of all, I think it's better if we rewrite this. I think let's write down 1 upon square root of 3 square minus 5x whole square. Okay, dx. Now compare it with a square minus x square. So what is that? Sine inverse x. What is x actually? 5x by a is 3 plus c. But remember, the coefficient of x will come in the division, 1 by 5. That's the answer. Okay, answer of the fourth, 1 by 5 sine inverse 5x by 3 plus c. Next question. Now if you look at this question, we have to integrate again with dx. Now the problem is denominator is close enough to a perfect square. We can write x square, x raised to power 4 as x square square and 2 as root 2 whole square. But the problem is numerator is also present. The standard form numerator is always 1 or some constant can be there. So this 3 is not a problem, but x is problem. So we have to do substitution. Also the formula is applicable only on squares, not power 4. So what do I differentiate? So I get x dx. If I differentiate x square as t, if I take it this, then 2x dx is dt. Okay. All right. So integration, this is 3 now, but we need 2. So what you do is you take this 3 outside, then multiply by 2 and divide by 2. So the outside there will be 3 by 2, then 2x dx, and denominator I can write this as 1 square plus root 2x square whole square. Okay, and now you have your substitution. This is dt, x square is t, so it can be written as 3 by 2 integration dt. It is not in square root, no? So 1 square plus root 2t whole square. Okay, fine. Now we can apply the format a square plus x square, or x square plus a square basically. So if square root is not there, that means tan inverse. Okay, the confusion is always regarding whether the log will come or tan will come or sine will come. So if no square root, the answer will be, for plus it is tan inverse, for negative it's sine inverse. Okay, a square minus x square. All right, one second. I'll write this as capital X, otherwise it will create confusion. Now let's continue. 3 by 2, this is x square plus a square, so answer is 1 by a is 1, so 1 by 1 tan inverse capital X. What is our capital X? Root 2t by a is again 1 plus c, but remember the coefficient of the variable, this time it's t, so another root 2 will come. So basically 3 2, if we readjust this, so this is 3 by 2 root 2 tan inverse root 2t plus c. This is the answer of this question. Root 2 t, but our answer should be in x, no? So 2 root 2 tan inverse root 2 x square plus c. Final answer is this, of course. So next question. So far what you have seen, we are doing some substitution, and after that it becomes a standard form. That's the idea. So somehow we are combining two topics and using the result of another topic. Okay. So again integration dx. Again x square is with dx. What do you take something as your t, so that you get x square as your differentiation of it? So you take, let x cube as t, increase one power basically, plus 1. So 3x square dx is dt. So this integration 3x square dt. So we don't have 3 here, so multiply by 3, divide by 3. So this becomes 1 by 3 dt 1 minus x raised to power 6 is x cube whole square, so t square. Now this is 1 can be written as 1 square, so a square minus again x square, like that. Okay, there is no coefficient of t, so we don't have to worry about that. So we can directly write down the result. 1 by 3, that will be log, first is 1 by 2a, so 1 by 2a is 1. Okay, then log a plus x, so a is 1 plus t upon 1 minus t in the mod plus c. Okay, so this is 3 into 2 becomes 1 by 6 log 1 plus x cube upon 1 minus x cube, okay, plus c. Okay. This is done. Let's look at the next one. Space, we'll use it here. So integration again. With respect to dx. This time the problem is numerator has two terms. Denominator is x square minus a square. We know the integration of this. This is square root of x square minus a square, standard result. But it's the numerator that is creating a problem. So what we can do is I can rewrite this in two parts. X upon square root of x square minus 1 minus 1 upon square root of x square minus 1 dx. Okay. So what is the integration of this? This is a standard result. So pretty much writing this in standard form. How to integrate this? You have to think. Again, if you look at x is there, we integrate this in two parts, okay, like this, split this also. Now you see x with dx and you think that if x square was t or x square minus 1 itself was t, okay, if we take this as t, let's use highlighting, and we multiply this by 2 and divide by 2, what is the differentiation of x square minus 1? 2x dx. So that will become dt. So this whole thing will become dt. I'm doing a lot of step in one step. I can show multiple steps, but takes more time. So 1 by 2, numerator becomes dt by square root of t minus integration of this x square minus a square, standard result, log mod x plus same denominator, x square minus 1 plus c. Okay. So this is what is 1 by root t integration, that's 2 root t minus, copy this, so root t was x square minus 1, so square root of x square minus 1 minus log mod x plus square root of x square minus 1 plus c. Okay, this is the answer of this question. All right. Next result. Next question. Again, the moment you see x square dx, we have done now 2-3 questions based on this. You know what you have to do. Multiply 3, divide by 3. Why? Because we are going to take, let x cube as t. Okay, so 3x square dx is dt. Okay. So 1 by 3 integration dt upon, this is square root of t square plus, we cannot write a raised to power 6, we need something square, so I'm writing a cube whole square. Okay. Now this is your x square, this is your a is already written, so I'm writing capital A to avoid the confusion. Okay. So this becomes 1 by 3 x square plus a square integration is, again I'm writing to the basic formula first, x plus square root of x square plus a square to avoid any confusion. Then you replace the value of x in capital A, okay, in order to avoid any confusion, plus c. So 1 by 3, what was our x? Actually it was t, so t plus square root of t square plus a is a cube, again whole square is, so same thing, a raised to power 6 plus c. So this is 1 by 3 log, what was our t actually? T was x cube, so x cube plus square root of x cube was again x cube whole square is x raised to power 6 plus a raised to power 6 plus c. That's the answer. Okay. All right. I think we are getting close. Like 1 or 2 questions, then we'll be done with the basic form of these results, standard results. So from now onwards, if I say a question can be done by standard result, I'm talking about these 6 formulas first of all, and additional 3 formulas are also there, but we'll talk about that in the few minutes. Dx. Okay. Again, sec square is with dx. So what do we have to take t as? Let tan x as t, because that will generate sec square x dx as dt. All right. So this numerator becomes dt, the denominator becomes integration dt upon t square plus 2 square. So x square plus a square, 1 by a, so 1 by 2 tan inverse t by 2, x by a, basically x is t, a is 2, plus c, so basically 1 by 2 tan inverse, oh nice, tan inverse tan x by 2, sorry, tan inverse tan x up, this is upon 2 with t, means upon 2 with tan, not x by 2, okay, plus c. Can we cancel this? Should I cancel this? Tan with tan inverse. The problem is if we write like this, you might think it's correct. I'll rewrite this. So what is actually written is 1 by 2. This is tan inverse 1 by 2 of tan x. And now you'll see that actually we cannot cancel this tan with tan inverse with this tan, okay, because there is a 1 by 2 present. So because of that we cannot do that. So this will be the final answer. Okay. One second. I think I missed. Oh, sorry. There was a square root present. Oh, I missed a square root. That's why I was saying why it is coming tan inverse like this. Anyways, if that was the question, so you could have done it. So now let's change it. So this is now square root now. So square root x square plus a square is log mod t plus square root of t square plus 2 square, that's 4. Copy the same denominator. Plus c. What is t? Log mod tan x plus, this is okay now, tan square x plus 4 plus c. Okay. Now it's correct. All right, we're done with this. Now again I'll discuss the questions in terms of forms. Okay, first form, because see, lot of integration is there, so sometimes majoritively actually we have the tendency to forget which form, what kind of integration is done by which form at n1 upon. So I'm categorizing again this in the form. First form, I'm talking about 1 upon q, or q means quadratic, or 1 upon square root of quadratic if you have the integration in this form. Okay, whether it is quadratic or square root of quadratic. Okay, so what we do with this, only one thing you have to remember: make perfect square, and that's it. Automatically things will happen. You have to make perfect square, and now you have to learn how to make perfect square for any quadratic equation. Okay, let's look at this with the help of a question. I'll take a simple one first. Let's take this one. what do you see? 1 upon quadratic. Okay, this is a quadratic equation. The moment you see, all you have to remember is make perfect square. How to make perfect square, that you have to learn. So let's understand. So x square, integration we'll do later. So we have x square plus 2x plus 2. In order to make the perfect square, there are certain conditions that you need to follow. First thing, make sure the coefficient of x square is 1, which is already 1, so good. If it is not, you take it out common by force. Okay. Then whatever is the coefficient of x, you take that coefficient 2 divided by another 2. Okay. If it is 2, divide by 2. If it is 3, divide by 3. Whatever is the coefficient of x divided by 2. Okay. Then what do you get result as? 1. You add 1 square. You add, subtract also 1 square. Okay. I'll repeat the step. Make sure the coefficient of x square is 1. Take the coefficient of x divided by 2. If it is 3, divided by 2. If it is 4, divided by 2. If it is 5, still divide by 2. Whatever number you get, you add whole square of that number, you subtract whole square of that number. So basically adding 1 square and subtracting 1 square. And you look at this term. Automatically this will happen always. Okay. X square plus 2x plus x square plus 2x plus 1. What is this? It becomes better right now. This, let's remove this constant. Let's write it later. Now this is easy to understand. So x square plus 2x plus 1 square, that is x plus 1 whole square. So this becomes x plus 1 whole square minus 1 square plus 2. So this is x plus 1 whole square minus plus 1 basically. Okay. So now this question is actually integration 1 upon square root of x plus 1 whole square plus 1. And now it is a standard formula. So basically if you get any quadratic equation in the denominator, first of all you have to make the perfect square, and then you get yourself a standard formula. It's as simple as that. Consider this as 1 square. So same thing, capital X square plus a square in the denominator with square root. So answer will be in log capital X. What is capital X? X plus 1 plus, copy the same denominator, x plus 1 whole square plus 1 plus c in the mod. Further, if you look at the answers, this will be further solved down, and you open it and solve it. But literally you don't have to open it, because you know where this came from. This was actually this x square plus 2x plus 2. So this is nothing but again x square plus 2x plus 2. So no need to solve this again in the mod plus c. Okay. This is the answer of this question. All right. Let's look at another question. I know the first time it's very typical to understand. This time let's take a question which coefficient of x square is not 1. Let's take 1 second. Rest are different. Okay, let's take this. So we have to integrate this. Again, you see, this is again 1 upon quadratic. Whether it is 1 upon square root of quadratic or quadratic, both follows the same thing. So make the perfect square. In order to do that, first of all, write the equation 9x square plus 6x plus 5. What is the first step? Make sure the coefficient of x square is 1. So I'm taking 9 common by force. So x square plus 6 by 9x plus 5 by 9. Weird? I know. So this 6 by 9 becomes 2 by 3. Take this coefficient divided by 2. So 1 second. Let me erase this. I'll write plus 5 by 9 later, because we have to add and subtract also, no? So write down the constant at last always. So what is this? 2 by 3 divided by 2 is 1 by 3. Okay. Multiply 1 by 2 basically. So you add 1 by 3 whole square, you subtract 1 by 3 whole square. Okay. This is the adjustment step. And now 9 is common. Okay, remember 9 is common from the whole expression. So 9 is common. This becomes, first three part becomes x square plus x square plus this is a square plus b square plus 2ab, no? So plus, so it is x plus 1 by 3 whole square minus 1 by 9 plus 4 by plus 5 by 9. So simply it becomes 9 bracket x plus 1 by 3 whole square minus 4 by 9. Okay, 4 by 9 is nothing but 2 by 3 whole square. Okay. Look at this. So this integration now becomes integration 1 upon 9 is common. So let's take it outside the integration itself. 1 by 9 is common. Now you have x plus 1 by 3 whole square minus 2 by 3 whole square. The making perfect square is a lengthy step slightly, but rest everything is pretty simple. X square minus a square. What is the integration of x square minus a square? 1 upon 9. This is 1 upon 2a. That means 2 into 2 by 3. Then log x minus a. Remember we are talking about capital X. So what is actually capital X? X plus 3. X plus 1 by 3 minus 2 by 3. X minus a, and then again x plus a, but remember x is x plus 1 by 3. This itself is in the mod plus c. So this becomes 3, 6, 12. So 1 by 12 log mod, take the LCM and solve it. This becomes 3x minus 1 by 3. No, this is, so 3x minus 1 upon, this becomes 3x plus 3 plus c. Okay. One very casual mistake. This was not negative. This was plus. So that means the formula is x square plus a square. So if it is x square plus a square, log will not come. Tan inverse. One single plus and minus mistake and you got yourself a wrong format of the answer effectively. But in MCQ, I think that will be easier to deal with, because options will be like for tan inverse, so you'll know. So this is 1 by 9. Yeah. So tan 1 by a. So 1 by 2 by 3. Tan inverse x by a. So x is x plus 1 by 3 and a is 2 by 3. Okay. So this becomes 1 by 6 tan inverse 3x plus 1 upon 2. That's the answer. And plus c, of course. Plus c. Okay. 1 by 6 tan inverse of this. And 1 by 9 was also going. 3x plus 1 by 2. Alright, this is done. Now you know at least how to make perfect squares. Now let's move ahead to the next format. There I'll teach you another thing about making perfect squares. Okay. Let's take for example, that was very typical. The values were actually, it's the values that makes the question problematic. Okay. Okay. Next format, let's do that. Okay. Next format is, there are two formats on this as such. One is 1 upon quadratic and 1 upon square root of quadratic. Second is linear upon quadratic or linear upon square root of quadratic. Means quadratic is present in square root or not, there should be a linear part present on top. Integration of that. Idea is still the same, make the perfect square, but before that what you have to do is you have to write a linear expression L as a times d by dx of quadratic plus b and find a and b. Okay. Then split the integration in two parts and solve it. I don't think everything can be learned from the formats. You'll have to see the example and understand what I'm talking about. Look at this question. First of all, you can see linear in the numerator and quadratic in the denominator. First you should be able to identify this is linear upon quadratic, so you should know that this is this format. Now what is the first step I told you? Now this is lengthy questions. You have to write this linear as a times d by dx of quadratic plus b, and you have to find a and b. What is linear? X plus 2. A d by dx of the quadratic, differentiate this, so you get differentiation of 2x square plus 6x plus 5 is 4x plus 6 plus b. X plus 2 is 4ax plus 6a plus b. You just compare coefficient of x with coefficient of x over here, and you compare your constant with constant. You get yourself two equations. With the help of it you can find a and b. Okay, clearly 4a is 1, so a is 1 by 4, and 6a plus b is 2, so 6 by 4 plus b is 2. B is 2 minus 6 by 4, so 8 minus 6, 2 by 4, which is 1 by 2. That's your b. You found your a and b. Now let's start with the integration now. Okay. I'll write the numerator x plus 2 using this. Okay. So integration, numerator x plus 2 will be written as a times a is 1 by 4 now, so a times 4x plus 6 plus b is 1 by 2. That's your a and b. Okay, and denominator is still the quadratic part, so what we'll do is we'll split this in two parts. Quadratic is 2x square plus 6x plus 5, and split it here also, 2x square plus 6x plus 5. Okay, integration of this. Okay, in fact better you break this into separate integration, not just like this. Dx with that, integration 1 by 2 dx with it plus. Now you have two integration. Why is that so important? This is nothing but 1 upon quadratic format. Okay, you have to identify the formats. This is 1 by 2 is constants, you can take it outside. This is nothing but a format of 1 by quadratic. You know how to solve that? Perfect square. What about this? This is the quadratic part and this is the differentiation of it. If you take this denominator as t, this whole thing becomes dt. Look at that. So this will be very easy to solve. So I'll solve this, I'll break down this in two integration. Let's call this as I1, let's call this as I2. The result is I1 plus I2. Okay, so I1 is 1 by 4 integration of 4x plus 6. I have taken 1 by 4 constant outside the integration. 2x square plus 6x plus 5 dx. Okay, I'm solving only I1. So t dt na, so let 2x square plus 6x plus 5 is equal to t. 4x plus 6 dx is dt. So the integration look like 1 by 4 integration dt by t. Okay. So what is that? 1 by 4 log t, not t basically. So 1 by 4 log t is 2x square plus 6x plus 5. This was your I1. Now let's solve I2. I'll copy this I2. So another practice, you try it on your own also. So I'm taking this 1 by 2 outside, so I have to make the perfect square, that I know. So make the perfect square. So let's rewrite this. This is I2, I have to solve. So perfect square is 2x square plus 6x plus 5. I'll take this as 2 common, x square plus 3x plus 5 by 2. Okay. In fact, write constant with some space. Then coefficient of x 3. Take it outside, divided by 2, that's 3 by 2. Okay. So that means you have to add 3 by 2 square, you have to subtract 3 by 2 square. And this first 3 terms becomes a plus b whole square. It can be a plus b or a minus b, depends on the question. So 2 bracket, this becomes x plus 3 by 2 whole square minus 9 by 4 plus 5 by 2. This time we'll have to be careful regarding the plus and minus because the formula changes. Okay, so x plus 3 by 2 whole square, this becomes 10 by 4, so plus 1 by 4, or 1 by 4 can be rewritten as 1 by 2 whole square. What's our I2 now? I2 is integration. Let's rewrite this. This integration becomes 1 by 2 integration of dx upon 2 times common we have taken from the denominator also. So that 2 will also go outside. So I'm writing 4 directly. X plus 3 by 2 whole square minus 1 by 2 whole square. Okay. So this is your capital X, that's your capital A or A. Okay. X square plus x square, again plus is there, no, sorry, format mistake. Okay, so plus is there, so x square plus a square, the answer will be in tan inverse. Okay, so 1 by 4 into 1 by a. What will be 1 by a of it will be reciprocal of 1 by 2. 1 by 2 is reciprocal is 2, or I can write 1 by a is 1 by 2 tan inverse x by a. X is x plus 3 by 2 upon a is 1 by 2 plus c. Solve this further, you'll get cancelling this, you get 1 by 2 tan inverse. Okay, this becomes 2x plus 3, 1 by 2 cancels, plus c, and that's your answer of I2. So you have your I1 result, you have your I2 result, combine them together in addition, that's your final result. Okay, so lengthy answer, but yes, that's it. All right, done. Let's take one more example, last one. Okay. Okay, I want to take negative is there. This time let's take quadratic in square root in the denominator. Okay, and make a correction in this question. This is negative, not positive. There's a misprint. All right. Again, format. What is in the numerator? Linear. What is in the denominator? Square root of quadratic, linear upon quadratic, or linear upon square root of quadratic. The first step is writing linear as a times d by dx of quadratic plus b. Okay. So x plus 3, a is times, we don't know a and b, we have to find that. Differentiation of this quadratic equation is minus 4 minus 2x plus b. So x plus 3 is minus 4, sorry, let's write x first, minus 2ax minus 4a plus b. Compare x with x, compare constant with constant. You get yourself two equations. You can easily find a first of all. So clearly minus 2a is equal to 1. A is minus 1 by 2. Minus 4a plus b. This negative will also be included. So minus 4a plus b is 3. So that becomes 4. This becomes 2 plus b. If we put the value of a, this is, and b is coming 1. Okay. So your a is coming minus 1 by 2, b is coming 1. So now let's start the integration. Okay. So we'll use this step. We'll write the numerator of the integration using this. A is minus 1 by 2, so minus 1 by 2 minus 4 minus 2x plus b is 1, and split the denominator. Okay. Denominator in two parts here. 5 minus 4x minus x square. 5 minus 4x minus x square. Okay, and split dx, integration also dx. Separately we have to do this in two integration, I1, I2. I2 is 1 upon square root of quadratic. You can solve that. And this is denominator t, substitution. Remember that this part will be done with substitution. So this is t, this thing is dt, not minus 1 by 2. So I1 I'm doing directly now, minus 1 by 2 integration, numerator becomes dt, denominator becomes square root of t. Okay, so minus 1 by 2 into 2 root t plus c. So minus root t is 5 minus 4x minus x square plus c, or let's say c1 if you want. Okay, I forgot to mention that since we are doing two integration, your final answer should have only one single c. Okay, it doesn't matter, because suppose you write c1 here, you write c2 for another integration I2, combine them, c1 plus c2 is some another constant, that is c. Okay, so don't worry about the constant I2. For that we have to copy, I'll solve it here. This is our I2. Let's solve it. For that we have to make perfect square. So now the problem is 5 minus 4x minus x square. You cannot directly make this because the coefficient of x square I told you should be 1. It's not 1. So what do? I rewrite this as, taking the negative common, I write 5 and change the sign. X square minus will become plus 4x minus 5. Okay. You do the same thing. Minus x square, minus x square plus 4x minus 5 right down here. Half of 4 is 2, so plus 2 square minus 2 square. So minus of this becomes x plus 2 whole square minus 4 minus 5 minus 9, so minus 3 square. Now let's multiply this negative inside, so it will change the order. So that will be 3 square minus x plus 2 whole square. That's it. Now let's solve this integration. This becomes integration 1 upon square root of 3 square minus x plus 2 whole square dx. That is the standard result, a square minus x square. Okay. What is square root of a square minus x square? That is sine inverse. Okay, so sine inverse, I haven't put the space. Okay, so sine inverse x, capital X by a. Capital X is x plus 2, a is 3 plus c 2, because we are doing I2. Okay, final answer I1 result plus I2. Okay. All right, that's pretty much it. If you want, I'm giving you 2 questions more for practice. You can practice that. Okay, let's take, I'm giving you like 4-5 questions. You can practice this. This 3 is inside the square root. Okay, and for this, don't get worried. You multiply this and generate quadratic. Okay, multiply, and then you'll get a quadratic, and then you'll do it normally. Okay. Multiply. So these are the questions for practice. Do try that. Okay. Standard NCERT questions. All right. Okay. Okay, that's it. We're done for this session. See you in the next class. Good day, everyone. Bye.